Today for my lecturer Dr. Ahmad FIRDAUS bin ZAINAL ABIDIN and friends. My name is Tua Yong Liang and my metric number is ZA19103. Today I'm gonna to present about the BCN3033 Network Programming Project 1 with the title FMSH. What is blockchain system? Traditionally, there have been a middleman who have been controlling the data. For instance, Facebook is the middleman between users and the advertisers. Banks are middlemen between borrowers and lenders. The issue here is that the data is controlled by a central authority like Facebook and bank. Therefore, they control the price and technically own the data. In this scenario, all the power lies with a middleman and users must trust them to remain ethical and continue to think about user interest. Blockchain was invented to make the data decentralized and trust minimized with any centralized party. There is no file owned by a single person. It is a kind of peer-to-peer architecture where multiple copies of the file are presented at multiple workstations or users. Therefore, no single person controls that file. This kind of architecture is highly scalable and fault tolerant since there is no single point of failure. One of the well-known use cases of blockchain is that of cryptocurrency, which is a digital currency that is not controlled by any central authority. Similarly, we can use blockchain for smart digital contract where no middleman is verifying the context. FMSH offers C++ for developers to develop the blockchain system. The FMSH has been designed to allow developers to easily access its routines and make use of the network without dealing with all the related blockchain technology. This library can be used to do anything that is allowed according to the Steam. FMSH offers C++ for developers to develop the blockchain system. The FMSH has been designed to allow developers to easily access its routine and make use of the network without dealing with all the related blockchain technology. This library can be used to do anything that is allowed according to the FMSH blockchain protocol. This is the part that I and my group mates in charge for. I will be responsible for buying function. The buying function should assign a local address to a socket identified by descriptor socket that has no local socket address assigned. Socket created with the socket function are initially unnamed. They are identified only by their address family. The bind function takes a few arguments. First, socket. Specify the file descriptor of the socket to be bound. Second, address. Points to a socket address structure containing the address to be bound to the socket. The length and format of the address depends on the address family of the socket. Third, address length. Specify the length of the socket address structure point to by the address argument. The socket specified by socket may require the process to have appropriate privilege to use the bind function. What can we relate between the network functions and the blockchain code? We can discover that the network function that we learn in this network programming subject is useful in developing blockchain. Therefore, by learning deeper about the network function, we can develop blockchain as well as develop a voting system. From the network function, bind function, and the blockchain system, I discovered that the bind function is one of the important functions that used in any blockchain. Without bind function, the blockchain system cannot begin communication with the client since the server socket is not bind to the port. There will be no record at the server, which in blockchain system, this feature is needed. So it is useful to have bind function in the blockchain system for it to functioning well. If we learn much more about network function, we can develop the new blockchain system or cryptocurrency that will implement network function and blockchain code as well. The suggested area that need blockchain method is cloud computing and storage. Blockchain cloud storage solution take a user's data and break it up into tiny chunks of data. It then takes these chunks of data and encrypt them to add an extra layer of security and distribute them throughout the network. This is done by using blockchain features such as transaction, ledgers, cryptographic hash function, and public or private key encryption. The data that is being stored throughout the blockchain ledger is split up and hashed a significant number of times. More importantly, the different chunks of hash data are not stored on the same storage device. They are split randomly throughout the network. This ensures that even if one bad actor were able to decrypt a piece of data, they will not have access to the entire file. The node would also not be able to identify who the data belongs to, so that the true user remain anonymous. As a final safety precaution, when a user goes to take back their data, those copies are compared to make sure they are all identical before the host get paid for their storage service. If something does get flagged, indicating that a node attempt to manipulate or alter data, the user will be immediately removed. There are many nodes required to make a quick transaction. Blockchain cloud storage will be affected if a node goes down, and it may affect the network. Users Users may worry that should a node hosting their data be deactivated, it will result in a class of file. However, this is not accurate. Due to the vast number of nodes, when one goes down, it's not very noticeable. Many storage services ensure that data is redundant. This means that more than one copy of data is stored in multiple locations. Should one node fail or leave the data network, a user will still be able to access their file. Each node that is active on the network increases the speed of the transaction. The more nodes running, the faster user can transfer data or complete a transaction. Comparing blockchain cloud storage to traditional storage solution, the flexibility is the huge difference. As you can see, the more access you need to the data, the higher the price you need to pay. This is what blockchain emphasizes as the important factor. The nodes for blockchain storage get paid when someone accesses their storage and download it. Due to this, it makes sense that the more you access your storage, the more you must pay. Even with this in mind, if you want storage that is not an exact terabyte or other fixed amount, then the blockchain option is superior. Depending on your preference, the blockchain storage solution allows many ways to save money as opposed to the rigid structure currently in cloud storage. Since our project source code cannot run, so our group finally found a new blockchain project that can be run perfectly. That is blockchain voting system. Now I will demonstrate how the blockchain voting system runs. Now I will show you how to run the blockchain voting system. First, we need to run the command prompt. After done running the command prompt, I will change the directory to the location that I save my project. After done, change the directory. Now I will run the blockchain function. Okay, the server function is done. Now I will go to the localhost. This is the simple GUI version for server blockchain system. Now let us continue to the client blockchain function. Also the same step, we need to open the command prompt, and I will change the directory again. Now I will open the client blockchain function. Okay, the client blockchain function is done. Now let us go to the localhost. Okay, this is the simple GUI function for client blockchain system. Now let me demonstrate for you. There's a sender address which called public key and the sender private key. And now I click the general wallet, and we can see the wallet is now generated. Now I will choose the Democrat and click the word. We can see that the client function is generate a new transaction. Now we confirm a vote. Once we click the confirm vote, the server function will receive a new transaction. Next we see, we can see the first block, which called Democrat, which is the recipient address, and we mine into the block. We can see first block is the recipient address, which called Democrat. And the second, now let's generate another. And now this time I choose Republican and click the vote again. Confirm vote. Okay. And we refresh again. As you can see, Republican is added into the block. Now we will mine the block. Here we can see Democrat is have one, Republican also got one. So the Democrat will connected to the second block, and the second block, which is Republican, and the Republican will connected to the third block. What is the third block? Now we generate again, which is the third block, Democrat and vote. Here again, we refresh. The votes that be added to the next block is Democrat. Now we mine into the blockchain. Here, the Democrat become 2, Republican still is 1. Now we can see Democrat is now added to the blockchain and connected to the fourth block. You can see through the command prompt, transaction get. Once we click the confirm vote at the client blockchain, and the server will receive a transaction. Once we mine into the blockchain, and a chain will get. Once we generate the wallet, the client will generate a new transaction, and once we vote, a new wallet will be generated. That's all for the demonstration of blockchain voting system. That's all from me. Thank you.